Okay, we're doing first principles in this video. Now, this is going to be a combination of both first principles and just general chord questions. Sometimes I'll ask you what happens when 2 points get closer on a graph and what happens to the slope, and other times they'll just flat out ask you a first principles question. So we'll have a look at both on this function here. First thing they're asking is the slope of the chord between x equals 1 and x equals 3. Now what they actually mean is they want you to get a straight line between x equals 1 and x equals 3. And basically just find the slope of that straight line. So literally nothing to do with calculus quite yet. You can see the slope of that straight line is going to be a little bit steeper than the actual slope at x equals 1. So this is just going to be like an approximate of the slope at x equals 1. This point here, so the x coordinate is definitely 1, and if my function is 3x squared, the y coordinate is 3 times 1 squared, so 3. This bit here, x is 3. And 3 times 3 squared will give me 27. Now, the slope is going to be y2 take y1 over x2 take x1, which is the same slope formula from stage 1 methods. And then we just sub in the points. So y2 would be 27, y1 would be 3, x2 would be 3, and x1 would be 1. This becomes 24 over 2. Or 12. Alright, cool. Next we're going to find the slope of the chord between x equals 1 and x equals 2. So if I put in this point at x equals 2 and we look at the slope, well, that slope's going to be slightly less steep. Let's have a look. So this next point here is going to be 2, and if it's 3x squared, that's 3 times 2 squared, which gives me 12. Great. So the slope here is still going to be the same formula. y2 take y1 over x2 take x1. So that's 12 take 3 over 2 take 1, which is 9 over 1, which is just 9. So what do we notice about these two numbers? Well, okay, we start at 12 and we get down to 9, so it looks like the slope is getting smaller. How small will it get? Well, we'll find out. If the second point continues to move closer to x equals 1, what will happen to the slope? The value of the slope will approach the gradient of the tangent at x equals 1. And that's pretty much your stock standard answer here. So we can see it's getting smaller and eventually it'll level out at whatever the slope is when I take a tangent. Now, what's a tangent? A tangent is the line that just touches x equals 1, but doesn't go through it. Tangent at x equals 1. Okay, so we're going to use first principles to find the slope here. And that has the standard formula, which we see in our topic booklet. And it looks like this. Limit as h goes to 0, f of x plus h minus f of x all over h. Okay, so let's think about what this means. Well, if I've got my point here, here's x, and here's x plus h, then the height of this point would be f of x, and the height would be f of x plus h. So in this case, for example, we would have had h equals 2, because 1 plus 2 gives you 3. And this would be an example where h equals 1. And if we want the slope, we're just going to have to make h really small. So like maybe like 0.001 or something. Okay, so let's step out this step by step. Limit as h goes to 0. Now f of x was 3x squared. So we're going to get 3x plus h squared. Take 3x squared all over h. Now I want to mention that because we're looking for the slope at x equals 1, you can just sub 1 in place of x here, and it'll make it a whole lot easier for you. What I generally prefer is to get the derivative using first principles first, and then sub 1 in later. And that's because that method will work all the time. Because sometimes they just ask you for the derivative, but other times they'll ask you for a point. So this becomes x squared plus 2xh plus h squared take 3x squared over h. Now that bit in the middle there is using our rule that we learned last year. A plus b squared is a squared plus 2ab plus b squared. All right, let's keep going. So now we're going to distributive law it out. Three x squared plus 6xh plus 3h squared, take 3x squared all over h. Now at this point, anything without a h in it should cancel out, like that 3x squared minus 3x squared. And what you're left with is stuff that has h in it. Now it's really important that it all has h in it because our next step is pretty much always to pull out h as a common factor. So we're going to do that. So you get 6x left and then 3h. These then cancel off. Now you might be wondering why we did all this algebra, because it's a big mess. But the reason we did it is because we're trying to put h to 0. Now if we just do that here, you're going to get stuff on the top, but you're going to get 0 on the bottom, and we can't divide by 0. But by pulling out h as a common factor like this, look, we just don't have h on the bottom anymore. So now I'm actually going to set h to 0, and I'm just left with 6x. And we call that the derivative of the function. Derivative just means slope. So now if I want f dash of 1, it's just 6 times 1, which is 6. So we can see the slope starts at 12 and ends up at 9. It gets less and less steep, and it is approaching a value of 6. Now that's your basic first derivatives, and you're going to be asked questions like this probably in the exam. What happens as points get closer and closer? But you also need to know a few more functions using first derivatives. I won't do them in this video, but make sure that you know how to do these ones. F of x equals 1 over x is really important to know. And f of x equals square root of x. There's a silly trick for both of these. In this one, you have to cross multiply. And in this one, you have to times by the conjugate. And they'll quite often come up in exams.